Hello, for Data Communications and Network 1 class today. My name is Usana Tantulaves from Kasetsart University. Today I will talk about the transmission media. Okay, there are two types of the transmission media. The first one is called guided media. The guided media, sometimes we call the wire media. Okay, the wire media, they consist of a twisted pair or copper wire, and then coaxial cable and optical fiber. I think you may have heard of all of this before. In the guided media, we will concern with the type of the medium because different type of the medium is the singular of the media. Okay, so for different type of the medium, either it's twisted pair or coaxial cable or optical fiber, they have different characteristics. So we have to study what that characteristic is, and then choose the appropriate twisted pair for our work. Okay, that is like a design. Okay, the second type of transmission media is called unguided media, or we may call unwired or wireless. Okay, let's say wireless media. In this case, the medium is air. Okay, so all of this has air as the medium. Okay, we may have heard of the satellite communication, radio transmission, FM, AM radio, and other radio signals. Okay, the terrestrial microwave is a microwave transmission on Earth. Okay, satellite communication is a microwave transmission to the sky, to satellite, but terrestrial is related to Earth, so it's both terrestrial microwave and the satellite microwave use microwave range frequency. We'll talk about this in other clips in the next clip. In this case, since we have the same medium, which is air, so we're concerned with the bandwidth, okay? That is produced by the antenna. We also concerned with the frequency, okay? That this frequency range has this characteristic. Another frequency range has a different characteristic. So we have to know that characteristic in order to design the correct, the correct bandwidth for our application. In both of the media, there are three parameters that we want have to consider. Okay. The first one is the data rate, okay? The higher data rate, the better, okay, for the user, right? So that they can download the file very quickly if the data rate is high. Okay, so user want high data rate. And the data rate is closely related to the bandwidth, okay? Because if you have higher bandwidth, okay, or broader bandwidth, okay, it's easier to get the higher data rate, okay? So higher bandwidth, higher data rate, okay? So they are closely related. And also we have the distance as another parameter, because when you transmit the power, the signal power will go down with the distance. So you have to concern about this too. This is the electromagnetic spectrum for telecommunications. Okay, let me zoom in, okay? This axis is the frequency in hertz. And this is the voice frequency. Over here, VF, you can see that they have the abbreviation here, okay, over here. So you can see what it means, okay. So this is about 1000 hertz. So this application is like telephone, voice, music, okay. In this range, we use a twisted pair to transmit. Okay, so this is like the telephone line at home. And then when you go up, okay, you have the radio frequency. The radio frequency is like AM, FM radio, and television. Okay, and the cellular technology is mobile phone, right? In this range, okay, if you use air, so you will use the radio frequency. But if you use the guided medium, okay, you can use twisted pair and coaxial cable. Okay, coaxial cable will go up to 10 to the 9, twisted pair go up to about 10 to the 8. please keep in mind that this is not a linear scale, okay? 10 to the 9 is 10 times of 10 to the 8. So this is like log scale, it's not linear, okay? So this range is much higher than the lower range, okay? Okay, now let me jump to the another guided medium, which is the optical fiber. Optical fiber transmit visible light, the light that you can see. The frequency range is in the order of 10 to the 14 to 10 to the 15. 10 to the 14 hertz, okay, it's very, very high frequency, okay? So 1 megahertz is 1 million hertz, right? So this is 10 to the 6, 10 to the 12 is million hertz. So this is 100 million hertz, okay, so very high frequency. And so optical fiber is a breakthrough in terms of the bandwidth, okay? Before fiber optics, optical fibers, okay, there are two names. The bandwidth is really limited, okay, in the twisted pair and coaxial cable. Once fiber optic is used, okay, we have very high bandwidth, okay, so there's no problem with the bandwidth anymore with this guided media, okay. Now let's go down a little bit in the frequency. You have infrared, okay. Red is the lowest visible light frequency that we can see. So infrared is lower than red, okay. So we have infrared. You have laser here, okay. So this is in this range of frequency. Infrared we use in like remote TV and stuff like that, okay. We go down again, we have the microwave and the radar. We use it in the terrestrial and satellite transmission that I told you before. The unguided media here will be explained more in the next clip video, okay. And this is the abbreviation of the name of the frequency. Okay, now let's go to the next slide. The twisted pair. What is the twisted pair? Twisted pair is like actually copper wire, right? That twist together. So we have twisted pair here. This is the copper and this is the like insulator outside. Outside is the insulator, okay? And this is the picture that you may have been, you should be familiar with, okay? If you, sometimes you take it and take the copper from this copper wire and use it in the photo board, okay? This one, okay, you twist it to reduce the crosstalk. Crosstalk is a signal that go from different pair of copper wire to your pair of copper wire, okay? So by twisting it, we reduce the crosstalk. It's the least expensive medium, okay? Most widely used, have been used for a long time, okay? The first one that is used for both analog and digital signal, for telephone system, for Ethernet LAN, okay? If you send for a short distance, twisted pair is, cost effective, okay? So it's cheaper than the other wire. The disadvantage is that it's susceptible to interference and noise, okay? So when you have other signal around it, okay, sometimes signal get in, okay? So the signal will not be very good. It has also highest attenuation for the guided medium, so you require more repeater in order to transmit your signal for long distance. Coaxial cable, I think you may have seen this before. You can take a look at this also later. This picture you may compare with this one, okay? So you have two conductor here and separated by the insulator, okay? Two layers of insulator, okay? So this one will be less susceptible to interference and noise than the twisted pair. It has higher data rate and higher frequency. Used for cable TV, used for LAN such as the thin Internet and thick Internet. The 10 base, 2 base is the baseband, 2 is 200 meters, 5 is 500 meters. So the thin Internet use the thinner cable, coaxial cable, and it can send for a shorter distance of 200 meters. Thick Internet use a different thicker coaxial cable, something like that, and send for a longer distance of 500 meters. Now let's look at our stars, the optical fiber. Optical fiber can make from glass or plastic, so you also have plastic optical fiber, okay? You use the total internal reflection. We'll talk about this in a little bit, but you can see that it's kind of reflect inside of the core. This is the core, reflect the signal reflect inside of the core, the ray, okay? And this is the cladding. So you have two glasses, okay, with different index of refraction here, okay? And this is the light that come in. The frequency is this range. I talked about this before. In late 2020, there was recorded data rate of 1 petabyte per second, okay, or 1 million gigabyte. Oh, sorry, 1 petabits per second or 1 million gigabits. Okay, so very high data rate, but this is in the lab, okay, not commercial yet, and it's used in the land application and long distance trunk. Okay, so you can connect one country to another country. You can go underwater. Okay, or you can connect one city to another city, okay, because it has a lot of bandwidth, okay. Now the disadvantage of the coaxial cable is the cost, okay, it's more expensive, and the installation and maintenance is much higher, and requires specific equipment and personnel, okay, specialist. Now what is the advantage? Advantage is much outweighs the disadvantage, okay, because it has much higher bandwidth and data rate, okay. The commercial is like hundreds of gigabit per second, okay, and higher data rate, okay. It has much smaller size and lighter weight, okay. So the diameter is about your hair diameter, one hair, okay. So you can send, it's very light. You can combine like many fiber optics together and send in one cable as a chunk. It has big like PVC outside, something like that, and combine them together. I like to show this if we have, in class, to show you a video of the underwater cable. Okay, you can also search that in Google, the underwater fiber optic cable. Now, like how big it is. It has significantly lower attenuation, okay. It needs fewer repeaters, maybe several tens of kilometers, 40 kilometers, something like this, to have one repeater. Not susceptible to interference, noise, and crosstalk because it sends light. Light is at a much higher frequency than the electromagnetic signal that is like man-made, okay. So it will not be affected by that, okay. So it's very like electromagnetic isolation. Now let's look at the nature of light, okay. How do we do the total internal reflection? We have to send, okay, at a higher angle, okay, than the critical angle, okay. So this is lower than the critical angle, okay. Lower than the critical angle, then what happened? Suppose this is a critical angle, okay? Critical angle. Okay, so it will just go up like this. This one will just go in the interface, okay? If you send at the higher than critical angle, it will reflect totally, okay? So this is total reflection. Okay, so and this is a denser material and this is the less dense material, okay. So you want to do this to keep the light in the core of the fiber optic. The fiber optic has the core and the cladder, right? So this is the core inside here. So you want the light to be inside here. Now let's look at type of optical fiber. The first one is step index multimode, okay. This is the oldest one. That was invented. It have a rough change of the density of the material, okay, at the interface of the core and the cladding, okay. So you have, as I showed you before, you have many ray, okay. You have ray that go straight and then ray that reflect, okay. So it have dispersion because the signal will come, okay, at different time, okay, because it have different distance to arrive at the destination. This one, okay, is the cheapest, okay, and the oldest oldest type of optical fiber. For the next two, I will show you in another figure. Okay, but basically the single mode, you have only one line go straight. Okay, so no distortion. This is the graded index multimode here, and the single mode is here. Okay, so the first one I have told you before, the step index fiber has been explained in the another slide. You can see that the core is biggest. Okay, and this is smaller and this is smallest. Okay, this is about 8 to 10 micrometer. You see that there's a rough change of the index of refraction for the step index and for the single mode. Okay, but this is gradual change of the index of refraction. Okay, so you see that for the graded index, okay, gradual change less dispersion. Okay, because it's like kind of change a little bit like this, so the pulse look like this. Okay, so better than the step index. Okay, but for the single mode, there is only one light, okay, inside of the core, so there is basically no dispersion. Okay, very thin core. Other light cannot reflect. Okay, it's too thin. Okay, to have other ray. Okay, other than the one that goes straight in the middle. Okay, light source is highly focused. Okay, only light beam that parallels to the core can propagate. So no distortion of the signal and very highest data rate. Okay, if you search for the optical fibers, okay, there are so many like so much information. Okay, people have talked about this a lot, and if we meet live or something in class, okay, I will explain more. I will introduce you to more of the materials, okay, on this. But for now, this is the end of the video. Thank you.